Hello, my geometry students. Today is a bit of a practice day. So we almost have like 2 review days before our quiz, which is nice. So let's jump right on into it. The very first question, it's saying the measures of 2 consecutive angles of a parallelogram are in the ratio of 3 to 7. Find the measure of an acute angle of the parallelogram. So each of these, they're asking you to draw a diagram because it's going to be useful. It's basically your substitution for having like let statements otherwise. So a parallelogram, do the best you can to give yourself a cute little parallelogram here. Right? 2 consecutive angles, so in a row. So like these would be consecutive angles here in the ratio of 3 to 7. So ratios like that, we add an x in there. So 3 times x, 7 times x. To make it make sense, make the smaller angle 3x, the larger angle 7x. All right, if that's all they're giving us, then we have to recognize that those 2 angles together are 180 degrees. Add those guys up. So 3x plus 7x equals 180, which we know means 10x equals 180. And I hope your calculator's nearby. If you divide by 10, that's just going to eliminate the 0. X comes out as 18. But it says find the measure of an acute angle in the parallelogram. Well, there's 2 acute angles, 2 obtuse. So the acute one would be 3 times 18. And so if we do 3 times 18, that would be 54 degrees. All right. Number 2. We're just going to keep trucking through these notes today. You have a rectangle ABCD. So always start by giving yourself a diagram. You're maybe even marking that right angle to remind yourself. If it's A, B, C, D, maybe they connect, or excuse me, make sure they connect in that order. AC is then a diagonal. So diagonal AC is 2x plus 15, and diagonal BD is 4x minus 5. So these are the diagonals here. Find the value of x. Well, in a rectangle, diagonals are equal, right? Because it's not slanted, so it controls that length. So 2x plus 15 equals 4x minus 5. And then we're solving. I'm going to do multi-steps here. Move that 2x over, add that 5 on over so that I get 2x and then equals 20. Divided up by 2, x comes out as 10. So since all you're asked for is the value of x, done. Always make sure, reread the question. Did you fully answer it? Right? For number 3, they give you a diagram. So in the diagram, you're told it's a parallelogram. That's important. Find the measure of angle B. So over here, that's what we're looking for in the end. But you got to work with what you know. Opposite angles are equal. So if we can set 2x plus 35 equal to 5x minus 22, that'll at least tell us what we know about the angles that are marked. Same thing, the algebra here is not super crazy. You're just solving some quick linear equations. So we should get 3x. 35 and 22 will give us 57 here. And then you divide by 3. 57 divided by 3, x is going to come out to be 19. All right. Once you know what x is, plug back into A or C. So like, let's say I use the measure of angle A. It would be 2 times 19 then plus 35. So double 19 and add 35. That's going to give us 73. So if this is 73 degrees, then the consecutive angle should add up to 180 with it. So the measure of angle B should be 180 minus that 73 right there. So if we take 180 out of there, 107. That's your final answer. I love a question like that. Do you know the relationship? Can you solve? And then do you understand how to connect it to the part that's not being labeled? So just, throwing it out there since you have a quiz coming. Number 4, an isosceles trapezoid. Okay. One pair of opposite sides parallel, the non-parallel sides congruent. That's what we think of for an isosceles trapezoid. They're telling you it's WXYZ, where XY is parallel to WZ. Okay, so WXYZ, so that XY is parallel to WZ. All right, I think I'm looking good there. So diagonals YW and XZ are drawn. All right, and they intersect at V. Okay, so that little point there. If XV is 4.6, and then WY, let's see, that's the whole thing. Oh, okay, is 14.2. So that whole length. Find V to Z. So find this piece right here. All right, well, when it's an isosceles trapezoid, the diagonals are equal. So that works out nicely. So then that means that 4.6 plus what we're looking for has to be equal to the same length of the opposite diagonal, which was the 14.2. So we're just subtracting that 4.6 right there. And when we do that, X should come out as 9.6, or I should say that VZ comes out as 9.6. So the diagram really was just to understand, like, what are these measurements even representing, knowing that it's the diagonal and then taking it from there. On to the next page. You only have one more page of notes because really it's just so that you get a little smattering of all the different stuff we've covered, and then you'll have more time to go work on the homework. It's a little lengthy, FYI. All right, rectangle ABCD has diagonal AC. So if I go A, B, C, D, diagonal AC, angle DCA. So DCA, that angle right there is 30. And now it might not be drawn to scale, and that's okay. Find the measure of angle CAD. So CAD is what we're looking for. Well, there's so many ways to look at this, but one way to look at it is the idea that you have a nice little right triangle here. And I know that in any triangle, the angles add up to 180 degrees. So I know this one is 90. I got that one at 30. So the last one has to make it add up to 180 total. So if I go 180 minus 90 and 30, or minus 120, that would leave me with 60 here. Another way to look at it, you might have said, hey, parallel lines. Here's some congruent alternate interiors. And then these two together have to form a 90-degree angle. So lots of ways to approach it. Right? For the next one, you've got a parallelogram ABCD. Again, doing your best. I'm not the best drawer, but get your point across there. AC again is the diagonal drawn. So I'm going to go A, B, C, D, and then draw that diagonal. Angle D is 110 degrees. So that's good. My diagram kind of makes sense here. Angle CAD is 50. So CAD, that's this corner, would be 50. Find the measure of angle CAB. So CAB. So we're looking for that. All right. Couple things. The fact that it's a parallelogram, consecutive angles have to add to 180. And so right off the bat, that tells me that angle A has to be 180 minus the 110 from over here, which is 70. And so that whole angle needs to be 70. And so if part of it is 50, the other part would just be 70 minus 50, or 20 degrees right there. All right, next one up. You've got an isosceles trapezoid. Let's see, AB is parallel to DC. So A, B, C, D. Please make sure they go in order. All right, and those are the parallel parts. Cool. AD is congruent to BC. And now you know I'm guilty of always using pen, but let's say you drew it wrong and you have pencil. You can fix that. So make sure that this and this match the diagram you've come up with. All right, angle ADC. So ADC is 80. Find the measure of angle BCD. All right, so BCD is this guy right here. Well, in an isosceles trapezoid, the base angles are equal. So there's really nothing much to do for that first one. So the measure of BCD would just be 80 degrees as well. But if you keep going, they also ask you for angle DAB up at the top. All right, when these lines are parallel, these are little same side interior angles right there, which also consecutive angles, but sometimes doesn't always work for all pairs of consecutives here. But because they are on opposite parallel lines, absolutely, we can say that the measure of angle DAB is 180 minus the 80 degrees you got right there. So it's the supplement 100 degrees. All right, this next one coming up. Love this question because you really have to know your properties. The diagonals of a rhombus. All right, do your best. So think rhombus, just squish square. Your best to draw it so that all the sides look the same. Saying the diagonals have lengths of 12 and 16. So I'm going to draw in the diagonals here. Now, depending on how good your drawing is, mine's okay. What we should know is that when you have the diagonals drawn in a rhombus, they are perpendicular. That's really important here because what you're forming are little right triangles. The other thing you have to know is that the diagonals bisect each other. So instead of labeling my picture with 12 and 16, I'm really going to label it with half of 12 or 6 and half of 16, 8. So I'm going to call my shorter diagonal 6 and 6, my longer diagonal 8 and 8, just to make it match the picture appropriately. Now when it says find the length of one side of the rhombus, well, you have 4 right triangles. Focus in on one of them. So maybe you pick just one here. So if I focus in on that little right triangle, I've got 6, I've got 8, and I'm looking for this right here. This is where, because it's a right triangle, we can use the Pythagorean theorem. So Pythagorean theorem, A, B, C, we can do a squared plus b squared equals c squared. Just remember, c has to be the hypotenuse. And so when we do this, we have 8 squared plus 6 squared equals c squared. 64 and 36 will give me an even 100. And then when you take the square root, that comes out to be 10. So when it asks you to find the length of one side of the rhombus, that's going to be 10 right there. All right. Ooh, my dog is hearing something. All right, we got one last one. It says opposite angles of a parallelogram are 3x minus 20 and x plus 15. Find x. As long as you understand what opposite angles are, you should be able to draw a diagram and label it. So this would be 3x minus 20. This guy's x plus 15. This last one, go for it. This is your post video question. I want you to be able to set up an equation and solve for x. All right, awesome. Thanks for watching, guys. See you in class soon.